Hi, my name is Jonas Lamy. I'm a PhD student at the LYRIS laboratory in Lyon, in France. And in this video, we will talk about the structure, concept, and results reproducibility of a benchmark on Vesselness filters. The context of this presentation is medical 3D image segmentations. In particular, an accurate liver vessel segmentation is still an open problem. Most segmentation schemes integrate a vessel enhancement filter, also known as Vesselness filter. These filters have a big impact on the segmentation by highlighting the vessels and suppressing the artifact's intensity. However, it is difficult from the literature alone to compare these filters against each other. We created a framework that quantitatively assesses the quality of a Vesselness filter given a 3D input and the corresponding binary ground truth. For the workflow, we compute the filter output and choose areas of interest in which we evaluate metrics. In particular, we were interested in 3 areas of interest: the liver, the vessel's neighborhood, and the bifurcations. Because some filters might detect vessels really well, but introduce a lot of false positives in the liver. We have 2 datasets, the EarCat dataset with 20 CT scans of the liver, and a synthetic dataset with MRI noise and illumination inconsistency. The benchmark relies on a listing of volumes defined by the user to support different database architectures. To assess the quality of the enhancement, we use 2 steps. We first successively threshold the filter output, and then we compare the binary result with the ground truth. The metrics used are the MCC, the dice, and the ROC curve. We used 7 vessels enhancement filters spread over 20 years of the literature, including the gold standard Frangi and most recent state-of-the-art filters such as German, Zhang, and Rorpo. All these filters can be used independently from the benchmark. Each filter's parameters can be separated in 2 sets: the scale parameter and the methods parameters. In the benchmark, the parameter sets are represented by JSON items. This makes our benchmark able to create a command line used in the shell and retrieve the output result. In the benchmark experiment, the parameters for each filter are optimized in 2 steps. A first optimization step on scales parameters with fixed methods parameters, and a second optimization on methods parameters using fixed base scales found at the previous step. The optimization is realized over the best mean MCC across all volumes. So the reproducibility consists of reproducing the results from a different research team by using the same experimental setup. To do that, we provide a benchmark parameter file for each optimization step. This file also specifies the number of areas of interest, an optional enhancement area useful for learning-based algorithms, the number of thresholds that ultimately impact the sampling of the ROC curve, and an option to only keep CSV files for systems with low disk space. Here is a sample of a CSV file. We provide a Python script to aggregate results from all filters and compute higher levels metrics, such as the overall mean and standard deviation of the optimized MCC. Here we have the results of the first optimization step for both datasets, and here are the final aggregated results. Everything is available on a GitHub repository, as well as a link to the database used and a step-by-step tutorial to create your own benchmark experiment. We have an online demonstration so that you can test the filters on both IRCAD and Vesselness samples, but you can also update your own image. You can choose one of the 7 filters and tune the parameters. You can also specify the area of interest. And finally, you can visualize results with superposed ground truth. You also have access to a history of previous tests done on the server. We welcome people to integrate new methods, which is possible by adding a pull request on the benchmark repository and submit an issue on the online demonstration repository. As a bonus feature, you can embed the 3D visualization of one of your experiments using the HTML code example and updating the URL inside. In conclusion, 7 Vesselness enhancement filters are readily available for your own usage, as well as a customizable benchmark framework. Additionally, we provide an online demonstration for testing filters on your own data. So thanks for your attention, and feel free to contact me if you have any questions.